Today, I want to talk about testing AI apps. And I actually want to echo something that Philip just talked about, which is that iterating very quickly on an LLM application, right, is the quickest way of converging to the kind of performance that you care about. That's something that I have found working on my own applications and that my friends have found. And what we're going to talk about today is how testing is the key ingredient that allows us to get those iterations in and converge to the performance that we want. And this talk is specifically focused, on tooling for full stack engineers that are building AI applications, right? So I think we're switching from a paradigm in which most of AI applications were built by ML engineers, and now we've sort of seen that process democratized and become more accessible to different people. But I think what's missing, it's a gap in tooling, for people who do not have an ML background. So let me tell you a little bit about how we got started with this project. So I'm an ML engineer in Cruise, so I work on AVs and I focus specifically on testing. And my friend, he's a full stack engineer at a marketing company. And he was working on this really, cool little application that basically would allow a marketer to provide a description of a marketing message. And then it would create a liquid template for that. So this is a templated language. And what it allows, the marketer to do is to basically personalize the marketing message based on the, products that their users have used. So he built this. It was pretty easy, right? You can just use the OpenAI API. But then he ran into a hiccup, which is, well, now I have this. How do I test it? And he didn't really have a simple answer to this question, which feels very basic. So why did he struggle with this? I think the number one thing to be aware of is, AI systems are very different from a conventional software system, right? They're not deterministic. Even, if you set the temperature to 0, for example, if you change one word or two, it can change the output significantly, right? And it's really hard to write code tests, that can target, a system that's so sensitive in that way. Another aspect of AI-based systems that's important to consider is that sometimes the questions that we want to ask about these systems are very open-ended, right? So we're not trying to compare some output from a function to like a float, like to an integer, We're looking at open text, right? It could be, some sort of support agent that's generating a response to a support case, and that's a really hard kind of data to write, code tests for. So that's one of the parts that, for which AI represents a paradigm shift. The second thing that, we noticed when my friend was looking for a tool is that a lot of the tools that are available are geared towards ML engineers or non-technical users, right? So, a lot of the libraries that we saw online, they're written in Python, they're configuration driven, they're talking about concepts like labels, metrics, etc. And these are not the types of concepts that someone who's a full stack engineer might be familiar with. I was actually talking to someone earlier exactly about this. Another thing is that, outside of the code itself, like the guides and the documentation and the abstractions are not really written for the full stack engineering audience. And finally, for some of these tools, there's, unnecessary, sort of like UI or SaaS components that developers at least don't want. I will say, I think, in talking to a lot of people and having friends who are doing different companies, I think that there's definitely an audience for tools that are, lower code, right? But there's also an audience for, developers that want to work within their standard ID. And so I think there's sort of space for all of these people, in sort of this new realm of AI tooling. So what did we do? What we did to solve this problem was that we built Poyro, right? And what Poyro is a simple open source test-like framework that allows you to test your AI app in JavaScript. So let me go through each of these points separately. So it's simple. It literally has 2 functions in the SDK. It's the simplest thing you could use. It's open source, so you don't need a license to use it. You can just clone it and use it wherever you want. It's using vtest. So the most popular framework for testing in JavaScript is Jest, and vtest is a modern version of that. And it's no cost, which I thought was important because one of the things that made us hesitant to test our AI apps is that you had, some AI tests that you might want to run require you using an LLM to evaluate the output of another LLM. And you don't want cost to be the thing that prevents you from iterating quickly. So what we did in this case is that we give you the option to run a local L. And it might sound like that wouldn't work super well, but with the speed at which local LLMs and open source LLMs are moving, it actually works a lot better than we initially thought. So we wanted to give support for that. So one of the things that we have learned in talking to people is that, people are not lacking evaluation libraries, right? I think there's probably like, 40 of them, right? But what is missing is content showing what this looks like in real life. So that's where we've been focusing a lot of our energy, and what I'm going to be presenting for the rest of the talk is basically a case study where we worked with a company that was building a legal AI application and wanted to figure out how do we test this thing so that we know that we can trust it. So let's dive in. So what are we testing? I want to show you a screenshot of what this app looked like so you have a sense of what we were writing unit tests for. So we came into contact with a startup called Outlet AI, and they are building a legal assistant for revising sales contracts. The way that it works is they have a web app and you can upload a contract, and it's going to read the contract and it's going to find areas of the contract that are problematic, that are going to give the client risk, right? And so what you see here is the first step where you select which agents you want to run. Some of them are focused on just contract risk. Some of them are focused on compliance. Some of them are focused on negotiation. We're going to dive deep specifically into the negotiation agent. So here's an example for what a recommendation looks like. So this is a section of the contract, section 4, where we're talking basically what's being discussed here. I'll give you the TLDR. It's a little dense. It's discussing the pricing of custom services that the seller is going to provide to the buyer in addition to the core software. And it's basically setting the terms by which the seller and the buyer are going to agree in that pricing for those additional custom services. So this AI agent is basically identifying that there's a clause here in red where it's basically giving the buyer the freedom to charge the seller the freedom to charge the buyer whatever amount they want for the cost of the additional services. And what the negotiation agent's noticing here, if you look at the example, is it's noticing that this might make the buyer reluctant to sign this contract, right? Because it doesn't give the buyer any protection in terms of the services that might get done. And finally, in green, what we have is based on this reasoning and detecting this, bad clause, we're going to replace it with this new clause that's going to set some limits to, how the seller can basically assign costs to the services that they, provide to the buyer. So now that we understand the app, the question is, how do we test an AI legal assistant? And this is actually a question that we struggled with, right? Because, Outlet came to us and we're like, how the hell do we do this? How do you break down the concept of analyzing a sales contract, right? And actually make it into something testable, right? So the way that we went about it is, this is where working in the AV space was helpful, right? One of the things that I learned at Cruise is that, complex AI systems are just like complex software systems. But what I mean by that is that they're decomposable into components, right? So in a self-driving car, for example, you have different ML models, different AI programs, right, that are responsible for different things, right? And what this example is trying to illustrate, this is actually a project I worked on, is the example of a web agent. This is an agent that could, use AI to navigate your browser. And you can see that, this is a large system that can be broken down into steps, right? So one step might be you choose what action to take on a page. Do you navigate or do you interact with the current page? If you choose to navigate, how do you select the link to navigate to? So we can take this fairly sophisticated system and break it up into subcomponents. And then once we've done that, it's much easier to define what success means for each of these subcomponents, right? So for example, for this first one, if you're choosing what action to take on the current page, you might go through all of the, the pages that you want the agent to navigate through and basically write down what the actual action that it should have taken should have been, and then compare that versus the action that the agent actually took. And then you can calculate the accuracy of the agent in making this action selection. So, but the key thing that I want to give you to here, that I want you to take away is that, we can decompose any of these complex systems into subcomponents, and then we can come up with measurable objectives for each of those subcomponents to test. So the same is true of this legal AI system. I would say that it can be decomposed into 4 parts, and there's actually 3 critical ones that we're going to focus on. So the first part, if the system is obviously the input, right? So you're inputting a section in a contract, right? That's this whole blurb here, actually, ignoring the title here, just the paragraph, right? So this is what we're feeding into the system, right? And then the system is actually producing 3 distinct outputs for us. And how those are sequenced doesn't really matter. What matters is that we can decompose them into 3 outputs, right? So the first one is that we're coming up with a substring that we're going to replace in the contract, which is in red, right? And the way that we're going to identify that is by figuring out the index at which that substring starts within the larger section and the substring or the index at which it ends, right? The second thing that our system's generating is a proposed replacement string. So that's the string that's in the green. And this is, a component that we can test independently from the substring that we identified for replacement. And finally, the last thing that's a critical part of the user experience is to make sure that, we're providing a reasoning to the user that makes sense to them and that actually helps them be successful, right? This is not supposed to be an AI lawyer. It's supposed to be an AI legal assistant. The user at the end of the day needs to approve the changes, and if they don't understand them, then it's not going to be very effective, right? So we've decomposed the system into 3 parts that we can test, and now we can think about how do we assign measurable objectives to each of these, right? So the first one's actually really easy, right? We can read, like a test contract ahead of time. We, can consult with a lawyer, right, or consult with like our internal team, like which is the clause that should have been detected by this negotiation agent within this section, and then we can check how the actual substring that should have been detected by the system would compare with the string that was actually detected by the system. In the second case, this is the more ambiguous part of the system in terms of testing, and this is the one that we struggled the most with. So, we are generating a proposed replacement string, right? That's going to replace the clause that we removed. And what we wanted to figure out is how to measure whether the replacement is good, right? But whether our replacement is good from a legal perspective is a really open-ended and ambiguous question. So we had to, talk to experts, right, and figure out like what does it mean for, like a clause in a contract to be good. And we came up with some example criteria, right? So one of them is, well, if you insert a new clause into a contract, you need to make sure that it doesn't contradict the rest of the contract. Because if it does, it actually makes that section void, right? And, that means that your recommendations are actually damaging the contract rather than enhancing it. The second thing is, we want to not rely on the internal knowledge of the model that we're using for the AI application to come up with like recommendations. What the best practice is to go to a lawyer, compile a list of best practices, put that into a text file or a database, and then when our agent is reading the contract, we're going to pull from those to make decisions about how we're going to update it. So when we are going through a test contract, we want to make sure that we can attribute the change that we're proposing to one of these best practices that it's in our database. And this is sort of how we broke down this complicated question of how do you measure if a proposed clause in a contract is good into measurable objectives. And then we'll get to how we actually measure them. Finally, we need to make sure that the reasoning is good. And our definition of good in this case is that we wanted it to be accessible to someone who is a non-legal staff member for the startup, right? So, a lot of the startups that are needing to rely on this kind of software, the reason they need this kind of software is because they don't have a legal team. They're usually at an early stage. And so that means that you need to provide reasoning that's, accessible to someone who's not a lawyer. Great. So now that we've gone through that, I want to take these ideas in terms of how we broke up the system into tests and then see how they translate into actual unit tests. So here we go. So for those who are familiar with Just or JavaScript, you may, be familiar with this kind of syntax, right? So this is the way that we segment tests when we're using Just, right? Basically, a describe is just a chunk of tests that are related to one another, and an it, in this case, represents a single test case. And for this file is measuring that first, component that we wanted to measure. I'll go back here. So the first thing that we wanted to measure here is, are we finding the right substring in the clause that is problematic? Okay? So that's what this test is doing. You can see here that we have the full text for the section, right? Which we want as a reference because we're going to get a substring out of this. And what we've done is that we are going to basically, write down the expected value that we want our agent to extract for what that bad substring should be. So in this case, it goes from 83 to 347. And if I highlight that in this text, what it should be picking out is the last 2 sentences. So the last 2 sentences in this section are the ones that are problematic, and those are the ones that should be detected by our agent. Over here, we have, a method that's basically spoofing the action of our agent. And what it's doing is that it's reading the section, and then it's figuring out like what it thinks the problematic clause is in this section. And in this case, the agent is going to think that this last sentence is the sentence that has the problem in the contract. So the agent in this case is failing because it should be detecting these last 2 sentences as problematic, but in practice is only detecting this sentence as problematic. So we're not detecting the full part of the section that has issues. Great. So having defined, our target substring for what we want to remove from the contract and what the system's actually detecting, which is, again, is this single sentence here. It's what it's actually detecting. We can use a method, just using code, to determine how much the substring that we want to remove overlaps with the substring that our system actually removes. And I'm not going to go through the details of this method, but all you need to know about it is that it calculates a number from 0 to 1. It's 0 if there's no overlap between those two substrings. It's 1 if they overlap perfectly. And if the overlap's not perfect, it's some number between 0 and 1. That's all it is. And so I can run this pretty easily here. So I will actually filter for this test, which is number 1. And here we go. So this is the output. So I actually have some logs here to show what's happening. So this is the problematic part of the section, right? This is the part that our AI agent should be extracting. And you can see that there's 2 sentences here. And this is what this AI system is actually detecting. So it's failing to detect the full text that is problematic. And so if I print out this overlap metric, it's saying that the overlap is only 50%. So I've only captured 50% of the problem text that I needed to detect with my AI agent. And in this case, it fails because we set the threshold to 80%, right? In practice, you're never going to get perfect accuracy for an AI system, right? So that's a reasonable threshold. So I hope that illustrates how you can use just simple code, even to taste an AI app. You don't necessarily need to do anything fancy to get started getting signal on whether your system's doing what it should be doing. So that was for the first case, which was basically making sure that we are highlighting in red the correct part of the section. Now we're going to go to the second case, and I think I might only have time for this one before I go to questions, which is, we want to check that the replacement that's being generated by our legal AI assistant is good, which again means that it's consistent with the rest of the section. So that's everything that's left here in white that's not deleted, right? And whether we can attribute it to some best legal practice, okay? Before I go into the code, I want to point out something that I think will help you understand how, how the code sort of plays out, right, or the test. So if you read the replacement clause here in green, you can see that it says here that the seller will provide binding estimates, right? What this means in plain English is that the seller is going to commit to a cost for their services, right? Which is the problem that was in the contract in the first place. But if we go to the white, you can see that, let me see. Yeah, so you can see here at the end of this sentence that we're not removing, that it says that the seller's estimates are non-binding. So what this means is that what we're keeping in the contract actually contradicts what we're inserting into the contract. So we actually run into this issue. And this is a real example. I didn't make this up. This actually happened. So now that we know that, we expect that consistency check to fail, we can go back to the test and understand it. Great. So that's this second file here. And so let me go back to the top. And actually, it might help if I just run it from the beginning. So we'll have that there as a reference. So as that runs, I will have that. Yeah, you're seeing like the outputs from the model or from the testing framework printout. So, you can see here we have the same section that we're working with, right? We have our first test, which is we want to check that there's not a contradiction, okay? And basically what we have here is that section minus the clause that we're going to remove. So this is the section text minus this red. It's the text in white, okay? So we're going to compare this with the text in green here to look for a contradiction, okay? So that's the replacement clause. This is the text in green in that picture. And so what we're going to do is that we're going to run this assertion here. And what this assertion does, it's really neat. It's basically, it takes that replacement clause, so that text in green. It specifies a natural language requirement, right? So an assertion in natural language. In this case, we're saying we do not want this to contradict any of the text that is passed in here. And as you might recall, this variable here is the text in white. And so this is actually, the addition that Poyro gives on top of vtest. This matcher is not part of vtest. This is what we've added to it to allow you to run what are called LLM-based tests, which is a test in which you're using an LLM to evaluate the output of another LLM. And when you run this actually by default runs locally on your computer, and it compares the text output by the application LLM, to your criteria that you specified here, and it returns a binary condition of whether it meets it or does not meet it. So if I go here, this is actually that first test that we just went through running. And you can see that it explains to us why it failed, right? We have this local LLM that's explaining to us why this criterion is failing. And in this case, it gets it correct, which is, it's saying, the response that you gave me in that first variable says that the seller's gonna, provide binding estimates. But the original text that you gave me says that those estimates are non-binding, therefore I'm going to fail this test. So, this is how, using LLMs for testing and extending v-tests with Poyro allows us to test some of these more open-ended cases, where it's hard to write code tests for. So that's the first case. In the second case here, we're looking to make sure that we can attribute the recommendation to a best practice. In practice, these best practices would come from some sort of knowledge base, right? It might be a text file, it might be a database. Here, for illustration purposes, I have them as an array, right? And, we also have our replacement clause, right? And what we want to do here is that we want to make sure that our replacement clause, which is this one, can be attributed to one of these, recommendations that a lawyer gave us that we put into our application, right? So if we reach through each of these, we can see that, for the first one, it doesn't make sense to attribute the replacement clause to this one, right? So the first best practice here says that the contract must establish a structured dispute resolution framework. Basically, it's saying that the contract needs to tell us how the seller and the buyer are going to resolve conflicts, right? But this replacement clause doesn't say anything about conflict resolution, and that was not the intent, right? So it's not going to match that first one. For the second one here, the best practice that we have here is saying that, we basically must have some, statement about warranties in the contract. And again, that's not the goal of this replacement clause, so we're not going to get a match between this one and that second one. But in the third one, in the third best practice here, we're checking, that the contract is giving financial clarity and planning regarding costs. And that's actually related to this recommendation. This recommendation is about making sure that the seller is communicating costs upfront to the buyer. So we would expect that we will get a match to this third one. So what we do is that we basically do a for loop across each of these best practices, and we run this function that Poyro provides. This is the second one that basically can, compare, some sort of input to some sort of context, through the lens of some criterion. In this case, the criterion is that we want to be able to attribute this replacement clause to this best practice, right? And you can see it's very simple. It's always 3 arguments, right? We're going to get, a JSON response. And then with that JSON response, we can basically check if we got a match for any of them. And that's what we get at the end of this for loop. So when we run that code, what we get is this right here, right? So I'm actually logging what the matcher is returning. And you can see that, as expected, the first best practice is not a match for the recommended update for the contract. So, we get a false, and we get an explanation saying, this is not a match because this is not talking about how to resolve conflict. For the second one, we also get a false, and it says, this clause is not, discussing anything about a warranty, so this is not a match. But for the third one, we get true, and it's because this clause that we're replacing with is establishing a way for the seller and the buyer to agree about costs, which is what we were checking for. Great. So I also have a third example. I want to leave time for questions, and I don't want to run too late, but let me go back here. So this is our repo. If you want to play with Poyro, there's a few reasons why you might want to play with this, or go to this link. Number one, this whole presentation is present there as an article. So if you want to go back and refer to it, you can read it. I know it's a lot of content, it's a lot of code, but you can go there and you can actually get the code in a runnable format. And you can also get an entire article explaining how we went through this thought process. The second thing is, we have docs that make it extremely easy to get started. It's a single command, and that will add v-test and Poyro to your project. And that will allow you to start writing tests like this. And finally, we have a lot of different examples there in different articles about how to write tests for other use cases. So we have, examples for like optimizing SEO. We have examples for like marketing, like the one I showed earlier, and we discussed some of those. Yeah, and we would love to hear from you. If you go there, you can find the link to our Discord. We love working with people and helping them brainstorm like how to test like their specific use case. That's what we did with Outlet for this particular example. Hearing about how you do evaluation and hearing your feedback. What do you think? That's a fantastic question. I kid you not. So my friend that's working on this with me presented today and got the same question. So this is a very common question. So there's different levels to this, right? The first one is that when you are training or you're using an LLM for evaluation, you can take a test set of evaluations, right? So just how you would evaluate, you can evaluate the evaluator, and you can actually check for the alignment between the evaluating model and human judgment. And one of the reasons why this type of testing has gotten popular is because people found that these LLMs were actually more aligned with human judgment than any sort of rules, right? So that's one way that you can go about it, right? The other way that you can go about it is there's actually, and this is something that we do before we update the model that runs. So there's a data set that was created by a team called Prometheus, and they have 100,000 examples of evaluations, right? And you can actually take the model, right, that we're using and the prompt that we have, and I can run it on like 1,000 of those, 10,000, 100,000, and see how often it's correct or not based on the Prometheus rubric, right? And then I've actually used that to iterate on the prompt or decide which model you use in order to do the evaluation. So I hope that answers your question. Yes, good question. So to answer the first question, what's happening here is we're actually prompting an LLM and we're asking it like, here's the output of your application LLM. Here is the rubric that you're going to use to evaluate that output. Do you think that this output meets that criteria, yes or no? So you could actually feed our prompt to ChatGPT and it would do the same thing, right? It's actually very, very simple, but it's been found to be really effective. And the output of that is a JSON, right? So this is coming straight out of that. You know, we basically tell it, this is the format that we want the response in. Can you just conform to that, right? And we have found that to work really well, and a lot of people have found that to work really well. And the reason, you know, this is additional content, but the reason why we generate the feedback, besides the fact that it's user-friendly, is that it also guides the evaluation, right? It's like a chain of thought, basically. I have not seen a lot of tools that are specifically tailored to Java. There's a lot in Python, there's a few in JavaScript, but I think that, you know, the set of support is slowly expanding to other languages.